Okay, moving on here. We're going to add another coupling cap on the audio output of the transistor there. It's a 220 nanofarad cap. So I'm going to add cap. I'm going to press C here. It should let me add a little cap. And I'm going to have it come from up here at the top where the voltage divider is, the collector of the transistor. And let's set this to 220 nanofarad. So I've got to type, I could do it over here if I want to. I never do that, but it's the letter N to get nano. I'm going to close that thing there. You can see it's a 220. And this is going to be our audio output of the circuit. And the cap is going to block DC from the battery so it doesn't go on to the audio equipment that follow. We need that DC to power the transistor, but we want AC, which is coming from the audio input, modulating the transistor and creating an AC output at the top of the transistor. We want the AC to pass, but not the DC. So that's what that coupling cap does. So we've got the main part of the circuit done here. That's kind of exciting. Good time to save if you haven't done that. We're gonna let's do some voltage measurements and check it out. Adding a voltage measurement, a probe up here at this green guy. I'm going to add a voltage probe, and I'm going to put it here at the beginning of the circuit. I'll put it right before the input coupling cap, and we'll put a second one here near the output. We'll put it right after right before the output cap, and you can do it before or after. You will definitely get different results. But let's do it this way as I've done it in the instructions, and we'll see what happens. And then up here, we're in interactive mode, which means it is interactive. And if you press play, you'll see it starts, and I'll stop it for a second. Let's see what's going on. We've got, it's measuring the voltage at this point, and this is an AC voltage here. And you can see at this particular moment, it's a sine wave, so it's either going to be negative, positive, it's always going to be changing. It's minus 50 millivolts. But the output is positive, almost 9 volts. So what's happening here is that the transistor is amplifying the input and giving quite a bit higher output. Now, you'll also notice this is a negative value and that's a positive value. That's because the output of the transistor is inverted in polarity. So whenever it comes in negative, it's going to come out positive, or vice versa. So that's a kind of a cool thing to see right here. We can see the amplification out in process, and we can also see the polarity reversal that happens through the transistor. I think that's all I got to say right now. Let's check it on the oscilloscope. That's kind of cool as well. If you go to split mode or grapher mode, we'll start with split mode. And I'm going to expand this out so it's not so silly. Boy, that's not looking really good. Let's press play. There we go. Now you can actually see an oscilloscope, and you could stop it or keep it rolling. It doesn't matter. But what we see here is the green input is down here. It's a little tiny sine wave. It's hovering, just barely both above and below 0 volts because, of course, it's a 50 millivolt input. The output is relatively sinusoidal. It's definitely clipped. One side of it is shaped different than the other. That's because the transistor is saturating, which is giving us yummy asymmetric distortion that we like with odd-ordered harmonics. That's why we want to do this for our guitar, so it's definitely changing the wave shape. But you can also see it's been amplified quite a bit. It's clipping here. It's seeing the top of the 9. It's hitting the end of the 9-volt power rail. So anyway, you can see that it's amplified and clipped, which is pretty cool, and it's asymmetric. And that's pretty neat. The other thing to see that's cool to view here is that the entire oscillation is above 0 volts. And that's because this is a Class A amplifier. And when you have the Class A amplifier, everything is amplified above 0. It doesn't dip in and out with different polarities above and below ground. So whereas the input is doing that, the output is not. And this is a Class A amplifier. We will solve this problem in a moment, if it is a problem, when we measure after the coupling cap. Cool? So I think for my assignment, there's a requirement at this point, is there not, to take a, yeah. So while you're in this split mode, And by the way, I didn't mention, but there are parameters for the oscilloscope. You can spend time tweaking this in viewing either one probe or the other probe. You can change the time division. You can change the voltage, the minimum, maximum extent. So you have a bunch of things you can do here. Closing that though, I do for the assignment, you need to take a screenshot right now. The whole page would be nice. So I can see your name on the assignment up there, and I can see your entire circuit. So zoom in, zoom out if need be to see the entire circuit, and show me that. Take a screenshot of it and name that screenshot 1 space scope dot your name, and you're going to submit this at the end of the assignment. Okay, excellent. So I'll stop here and we'll make another video and do the diode clipping in a moment. Bye bye.